Welcome to this presentation about the immune system. As we all know, the immune system is our body's natural defense system that protects us from harmful pathogens. It is a complex network of cells, tissues, and organs that work together to recognize and attack foreign invaders. The immune system is a remarkable biological process that involves a series of intricate reactions. Immune cells are responsible for eliminating threats, including viruses, bacteria, and other harmful microorganisms. They work together to identify and destroy these pathogens. A functioning immune system is essential for good health. It plays a critical role in preventing infections and diseases. In this presentation, we will discuss the various components of the immune system and how they work together to keep us healthy. Moving on to our second slide, let's talk about innate immunity. Innate immunity is the first line of defense against foreign invaders and provides a rapid response to pathogens. It involves physical and chemical barriers that prevent entry of harmful microorganisms. The physical barriers include our skin, mucous membranes, and cilia in our respiratory tract. These barriers prevent pathogens from entering our body. Chemical barriers such as stomach acid, tears, and saliva also play an important role in preventing infection. In addition to these barriers, innate immunity also includes specialized cells such as phagocytes and natural killer cells. Phagocytes are cells that engulf and destroy pathogens. They are like the Pac-Man of our immune system. Natural killer cells, on the other hand, attack infected cells that have been taken over by viruses or abnormal cells that could become cancerous. Together, these components of innate immunity provide a powerful defense mechanism against I. Now let's talk about adaptive immunity, which is a more specialized defense mechanism that provides a slower response but is more specific to particular pathogens. Adaptive immunity is activated when innate immunity is not able to completely eliminate a pathogen. Adaptive immunity involves two types of cells, B cells and T cells. B cells produce antibodies against antigens, which are foreign substances that trigger an immune response. The antibodies bind to the antigens and mark them for destruction by other immune cells. This process is called humoral immunity. T cells, on the other hand, directly attack infected cells. They recognize and destroy cells that have been taken over by viruses or have become cancerous. This process is called cell-mediated immunity. Adaptive immunity also involves the production of memory cells, which remember past infections and can respond more quickly to future attacks by the same pathogen. In summary, adaptive immunity provides a specific and long ill. Let's discuss antigens on our fourth slide. Antigens are molecules that trigger an immune response by activating B cells and T cells. They can be foreign, such as bacteria or viruses, or self-antigens, which are present in our own cells but can become abnormal and trigger an immune response. Antibodies, produced by B cells, bind to antigens to neutralize them and mark them for destruction by other immune cells. Antibodies are highly specific to the antigen they target, which allows our immune system to precisely identify and eliminate pathogens. T cells, on the other hand, recognize antigens presented by major histocompatibility complex (MHC) molecules on the surface of cells. This process is important in cell-mediated immunity, where T cells directly attack infected cells. In summary, antigens play a critical role in activating our immune system, and their specific recognition by B cells and T cells is essential in mounting an effective immune response against infections and disease. Let's discuss B cells on our fifth slide. B cells are a type of white blood cell that mature in the bone marrow and are responsible for producing antibodies against specific antigens. When a B cell encounters an antigen, it activates and begins to proliferate, creating many identical cells. Some of these cells become memory B cells, which can remember past infections and mount a rapid response to future attacks by the same pathogen. Other cells differentiate into plasma cells, which are responsible for secreting large amounts of antibodies into circulation. These antibodies can neutralize the pathogen, marking it for destruction by other immune cells. B cells play a critical role in humoral immunity, which is a type of adaptive immunity that involves the production of antibodies. In summary, B cells are an important component of the immune system that produce antibodies against specific antigens and remember past infections to provide protection against future attacks. On our sixth slide, we will discuss T cells, which are another type of white blood cell that mature in the thymus and play a crucial role in adaptive immunity. T cells recognize antigens presented by major histocompatibility complex (MHC) molecules on the surface of cells. There are two main types of T cells: helper T cells and cytotoxic T cells. Helper T cells activate B cells and other T cells by releasing cytokines, which are signaling molecules that stimulate an immune response. They are important in both humoral and cell-mediated immunity. Cytotoxic T cells directly attack infected cells by recognizing and destroying cells that have been taken over by viruses or have become cancerous. They are important in cell-mediated immunity. Similar to B cells, some T cells can become memory cells, which remember past infections and mount a rapid response to future attacks by the same pathogen. In summary, T cells play a critical role in adaptive immunity by recognizing and responding to. On our seventh slide, we will discuss the concept of immunological memory, which is a crucial component of the adaptive immune response. Memory B and T cells are long-lived cells that can remember past infections and mount a rapid and effective response to future attacks by the same pathogen. This is the basis of vaccination, which involves exposing the immune system to a harmless form of a pathogen to stimulate the production of memory cells. Immunological memory enables the immune system to respond more quickly and effectively to future infections, reducing the severity and duration of the illness. However, it is important to note that memory can fade over time, leading to a loss of protection against the pathogen. This is why some vaccines require booster shots to maintain immunity. In summary, immunological memory is a critical component of the adaptive immune response that enables a quicker and more effective response to future infections. Vaccination is based on the concept of. We will discuss immunodeficiency, which is a condition where the immune system fails to respond adequately to threats. There are two types of immunodeficiency: primary and secondary. Primary immunodeficiencies are genetic disorders that are present from birth and can affect any part of the immune system. Secondary immunodeficiencies can result from disease, such as HIV/AIDS, or as a side effect of treatment, such as chemotherapy. Immunodeficiency can lead to increased susceptibility to infections and cancer, as the immune system is unable to mount an effective response to these threats. Treatment for immunodeficiency may involve immunoglobulin replacement therapy, bone marrow transplantation, or gene therapy, depending on the underlying cause of the condition. In summary, immunodeficiency is a condition where the immune system fails to respond adequately to threats and can lead to increased susceptibility to infections and cancer. Treatment options depend on the underlying cause. We will discuss autoimmune diseases, which are conditions where the immune system attacks its own cells and tissues. Examples of autoimmune diseases include rheumatoid arthritis and lupus. These conditions can affect different parts of the body and cause a range of symptoms, such as joint pain, fatigue, and skin rashes. Autoimmune diseases are thought to be caused by a combination of genetic and environmental factors. While there is no cure for autoimmune diseases, treatment involves suppressing the immune response with medications such as corticosteroids and immunosuppressants. It is important to note that the immune system plays a crucial role in protecting our health, and suppressing it can have potential side effects, such as an increased risk of infections. In summary, autoimmune diseases are conditions where the immune system attacks its own cells and tissues. Treatment involves suppressing the immune response with medications, but it is important to balance the benefits and. On our final slide, we will summarize the key points of our presentation. The immune system is a complex network of cells and molecules that work together to protect our body against harmful pathogens while avoiding self-attack. Dysfunctions in the immune system can lead to immunodeficiencies, where the immune system is unable to mount an effective response to threats, and autoimmune diseases, where the immune system attacks its own cells and tissues. Understanding the immune system is crucial for developing effective treatments for various conditions, including infectious diseases, cancer, immunodeficiencies, and autoimmune diseases. As we continue to learn more about the immune system and its role in health and disease, we can work towards developing more targeted and personalized treatments that can improve outcomes for patients. Thank you for your attention, and we hope that this presentation has provided you with a better understanding of the immune system and its importance. Hi, I just wanted to take a moment to say thank you for watching my videos and supporting my channel. Your comments, likes, and shares mean the world to me and inspire me to keep creating content. If you haven't already, please consider subscribing to my channel. By doing so, you'll never miss a video and you'll be helping me reach more people with my message. I promise to continue providing high quality and engaging content that you love, so hit that subscribe button and join our community today. Thanks again for your support, and I will see you in the next video.